Hi all, welcome to Simple Engineering Simplified. I am Dr. Needu PS. Today we are going to discuss about Hamming code. Let's see one problem in the Hamming code. So find the Hamming code for the message data. The data is given as 1000 and the condition is given as consider this as an even parity bit. So we will solve this for the Hamming code. So our solution starts with you have the given is the data and data is given as 1000, which means our M is equal to 4 bits because 4 bits are given in your data. So next step is we have to find the number of parity bits. So number of parity bits we will find by using the equation 2 power r greater than or equal to m plus r plus 1. So we know that m is equal to 4, that we can substitute in this equation. So we will get it as 2 power r greater than or equal to 4 plus r plus 1. So which is 2 power r greater than or equal to 5 plus r. So when we will see this by substituting different values for r, if we are substituting r is equal to 3, so 2 power 3 greater than or equal to 5 plus 3. So 2 power 3 greater than or equal to 8, so 2 power 3 is 8, so 8 is equal to 8. So r is equal to 3, that is being satisfied. So we know that now we came to the conclusion that our parity bit is equal to 3 bits. So we got data as 4 bits and parity bits as 3 bits, which means that for a 4 bit message data, we need 3 parity bits. So for our Hamming code, it will be of 7 bits, which is your data plus parity bits. So we know that now 3 parity bits are needed for this Hamming code. But we don't know what is the position of our parity bits. So next step is we are going to find the position of parity bits. So we have 3 parity bits which we will mark it as like P1, P2, P3. So 7 bits is our Hamming data. So we will mark it as 7, 6, 5, 4, 3, 2, 1. So here we have to find what is our position of the parity and the 4-bit data where we have to place it. So first we are going to find the position. So how you will find is 2 power n, where n is equal to 0, 1, 2, 3, 4, like that it will go. And we know that we have only 3 bits as our parity. So n is equal to 0, n is equal to 1 and n is equal to 2. So these are the 3 n values which we will choose for our finding the position of the parity bits. So 2 power n, in that we will substitute 2 power 0 which is equal to 1. In 2 power n, where n is equal to 1, so 2 power 1 which is equal to 2. Then for 2 power n, n is equal to 2, so 2 power 2 which will be equal to 4. So we got 1, 2 and 4 is the position of our parity bit. So we will write P1, P2. As our 4th bit is the parity bit, we can write it as P4 instead of P3. So next will be the other remaining ones will be our data bits. So this we can take it as D7, D6, D5 and D3. So this is your Hamming code. And we know that D7, D6, D5 and D3, that is your message. So our message is 1000. So we can place 1, 0, 0 and 0 for this one. But we have to find what is our P1 and what is our P2 and what is our P4. So now we are going to find the parity bits P1, P2 and P4. So for that we have the equation P1 is equal to 357. P2 is equal to 367 and P4 is equal to 567. So for this P1 is equal to 357. Our third bit is 0, fifth bit is 0 and seventh bit is 1. And in the question it is given as you have to consider the even parity bits. So even parity bits means the number of ones in the bit should be equal to the even count. So here you can see that only one is there, which means this is odd parity. So in order to make this even parity, you have to mark your P1 as 1. Then if you consider P2, it is 3, 6 and 7. So 3 is 0, 6 is 0 and 7 is 1. Here also same. In order to make this to even parity, you have to make P2 as 1. Next is you have to find P4. So P4 is equal to 5, 6 and 7. 5 is 0, 6 is 0 and 7 is 1. Here also in order to make this even parity, you have to take P4 as 1. So you got P1 as 1, P2 as 1 and P4 as 1. So your Hamming code will be 1 0 0 1 0 1 1. So hope this is clear for everyone. If you find this useful, please share it with others. Thank you.